Today we're going to take a look at the next type of conic section. This is an ellipse. Now, an ellipse is formed from two fixed points. And so imagine we have like a string that kind of goes all this way. And then if we just keep moving that string around, and then the pieces become shorter or longer, and then they just keep switching, then of course this is how we get an ellipse. So it's not one point that an ellipse is drawn from, it's actually 2 points. And these points are called the foci. So what happens is this distance between these two pieces is a constant. That's how you make an ellipse. That's basically the definition. What you need to know are the parts. So there are two axes, and that's this picture down here. The longer axis is called the major axis. And on this major axis, it contains the things that kind of are the most important, which are the vertices and the foci. And then, of course, the minor axis is this shorter one. And so the minor axis is shorter, and that has the covertices. The center is where the major and minor axis meet. If I can write, where the major and the minor axis intersect. The vertices are the end points of the major axis, and the covertices are the end points of the minor axis, or the small one. So before we go any further, we're just going to go back through and take a look at this in a different way. If you can't identify these things, you're not going to be able to answer the questions. So while this seems like it's just definitions, this is really leading you to be able to answer the problem. So in this ellipse, this horizontal ellipse, the longer axis is the major axis. So this one is the major, this one. And on that axis, the end points are the vertices. Inside the the ellipse, are the focal points. The focal points always live inside. This is, of course, the center. And then these other endpoints, we just call these the covertices, here and here. And so on this other one, let's try it again. The major axis is the long one. This one's now the major axis. The endpoints of the major axis are the vertices. The endpoints of the other axis are the covertices. This is, of course, the center. And then along the major axis, the points that are inside here are the focal points. Now, how do you find these things? The vertices are adding and subtracting A away from the center. So the vertices from the center to the vertex, this is little a. The covertices, you add and subtract B. So going the shorter direction, this is B, and everything comes from the center. The length of the major axis, well, from the center to one way is A, then two of them would be 2A, and the minor axis would be 2B. And the focal points, and this is the one that matters probably the most, is lowercase c, away from the center. The way you find c squared equals a squared minus b squared. I'm giving you a lot of information, and then we're just going to go ahead and use all this information. Now, when you write the equation of ellipse, it's always a fraction and another fraction equals 1, always. And this kind of lines up. So like horizontal is this formula. It really doesn't matter because the pattern is very, very, very much the same. And if it's horizontal, the a squared would be underneath the x. And then the y and the b squared would be underneath each other. If you notice, the center on the top is just like a circle. if it's oriented the other direction. So if it's vertical, now a squared is going to be underneath the y, because a squared is always bigger, and that's the important part. I'll show you how to use this, but the big important thing is that a squared is largest. So a squared is the big one. It really doesn't matter which one's first and which one's second. Graphing these is really not much different than graphing a circle. We're just not going to count the same numbers in all the directions. So that's kind of the good news. I know it seems like it's super complicated, and it's really not, but you do have to know all these things, the A, the B, and the C. So let me show you how we're going to do this. So the center lives across the top. So our center, right, across the top here, we don't have any numbers, so the center's at 0, 0. I'm just going to put that right on the graph. Now, we know that the bigger one is a squared, so 64 is a squared. So what that means is that plus or minus 8 is a. Now, this is underneath the x, which goes this way. So from the center, you're going to count 8 left and right, because this is underneath the x. The bigger way controls your vertices. So this is a vertex, this is a vertex. I would try to do these one at a time like this. So we went 8, didn't go up at all, and we went -8, didn't go up at all. Now the co-vertices go with the b, so b squared is smaller. So 25 is b squared. So plus or minus 5 is b. Now this falls underneath the y, so that means we're going to count up and down from the center, 5 each. These are your co-vertices. So this is another co-vertex. You don't have to label it on the picture. I'm just doing this to sort of help you keep track of what's going on. I would graph it and then write the coordinates. Graph it and write the coordinates, just to keep it sort of clean. So the co-vertices, we didn't go up or down at all. We went up 5 and down 5. Now you can, of course, write these plus or minus 8, 0, and 0 plus or minus 5 if you want. So this is your ellipse. Now, c squared is equal to a squared minus b squared. So this is basically big minus small. It's not first or second, it's big minus small. So c squared equals 39. I would make this a decimal. So c is plus or minus 6.2. Now, for the focal points and the vertices do the same pattern. And if you look at this, it looks like we added to the x. So we'll do that with the focal points. So we're going to take 0 and add 6.24. So I see 6.2. And then we're going to subtract. That's real easy to do if you're starting with a 0. Let's do this when the center's not at 0, 0. So again, we're going to start with the center. Opposite, opposite. So across the top here, we do opposite, opposite, just like a circle. So the center is 5, -2. Put that on your graph. A squared is 36, which means A is plus or minus 6. This is the bigger one. This is underneath the y. So we're going to go up and down. So we're going to go up 6, and we're going to go down 6 from the center. So these are your vertices. The bigger direction are your vertices. So we went from the center, we added and subtracted to the y 6. So do the arithmetic, or count the squares on your graph. So we have -2 plus 6, and then we went 5, and then we did -2 minus 6. The co-vertices go with b. So b squared is the smaller one, which is 9. That's this one. So that means b equals plus or minus 3, and that's underneath the x, which means we're going to go left and right from the center. And so since we went from x, so this is from the center, we're starting at 5, -2, and we're adding and subtracting 3 from the x value of the center, or just read the graph, 1, 2, 1, 2. So we have 2, negative 2, and 8, negative 2. And of course, we'll draw this. Yikes, that's a pretty terrible drawing. Now we need to do c squared. C squared is bigger minus the other one. So 36 minus 9. So c squared is 27. Ooh, square root of that in the radical, or in the decimal rather, is 5.2. And remember, that follows the pattern of the vertices. So if you remember what we did for the vertices, I wrote it down here, right? We added and subtracted to the y value. So we're going to do that again for the foci. So we have 5, oh, hello. We have 5, negative 2 is our point. And from the y value, we're going to add and subtract 5.2. So we have 5. So we have negative 2 plus 5.2, so that's 3.2. And then the x value is 5, and negative 2 minus 5.2 is negative 7.2. You don't need to graph the focal points. You just need to write them down. Now, to put this in standard form, remember, this number out here needs to be a 1. So let's make that a 1. We're just going to divide everything by 225. When you do the division, kind of do it upside down so that you end up with a number in the bottom. So 225 divided by 25, make sure that number ends up in the bottom. And then 225 divided by 9 is 25. Sometimes it's like this. It seems like the numbers just switched. That happens sometimes, not every time. So we get x squared over 9 plus y squared over 25 equals 1. That's it. It has to be a fraction plus a fraction equals 1. Now, in a circle, when we completed the square, we didn't have to do any factoring. Because it's a circle, it was pulled evenly in all directions. But now we have this issue that this and this don't match. So we can't just divide. So instead, we're going to have to factor. And of course, the first thing we do is we rearrange this so that we have all the families together. So we're going to have 4x squared and then the 24x. Then we're going to have the y squared. There is no plain y term, and this 28 is good. It's not supposed to be on the left. Keep all the plain numbers over here. So these first two have a 4 in common. You have to factor that out because in order to do completing the square, this needs to be a 1. So we're trying to force that to happen. When you complete the square, you do it inside the parentheses. And of course, whatever we add to one side, we're going to add to the other. Now, as far as this y squared goes, there is no y term, so there's nothing to take half of. We saw this with the circle the other day, so we can't complete the square there. It's not possible. So now we're going to complete the square. Half of 6 is 3. Oh my goodness, what is going on with this thing? Sorry. Half of 6 is 3, and 3 squared is 9. That's going to go here. But you really added 9 times 4, so you have to add 36 to the other side. So remember the pattern. Letter, first sign, number you squared. Then we have the y squared. Over here, you just do what it says, and that gets a 64. Now we work our way backwards. So we're going to start at the 64 and divide everything by 64. Oh, I left my 4 out. When you do this division, make sure you end up with the number on the bottom. So this will be x plus 3 quantity squared over 16 plus y squared over 64 equals 1. One more time for fun. You know what to do first, hopefully. We reorganize. 9x squared minus 36x plus y squared plus 10y, 52, move it to the other side. Factor out the 9. So we have x squared minus 4x. Complete the square inside the parentheses. We don't have to factor anything out here, but we do have to complete the square. And on this side, we have negative 52 plus 2 more things. Half of 4 is 2. 2 squared, we're going to add 4 to this side. But remember, it's really 4 times 9, so we're adding 36 over here. Half of 10 is 5. 5 squared is 25. And we're adding 25 to both sides. 9 stays. Letter, first sign, number you squared. Letter, first sign, number you squared. Right-hand side, do what it says. When you add all that stuff up, you just get a 9. Now we work our way backwards and divide by that. These are gone. You can either write this one or not. As you know, it doesn't really need to be there, but it helps if you were to graph it. It would help to have that there. I'm just going to put it there. It's not necessary, but I like to have it there. And this is the standard form.